So we are now starting with a little bit on multimodal embeddings. A bunch of my audio files got corrupted last week, so we're gonna kick it off with a new episode and publish 2 episodes this week. And we will be talking a lot about how to fine-tune embedding models, how to use multimodal AI in the enterprise, but multimodal embeddings especially come with a lot of pain. And a large portion of that is because of storage and serving. Because you often in the enterprise have different access patterns to embeddings, and you often have to go with multiple storage solutions at the same time to store the different parts what makes up in multimodal embedding. So you typically store the source data as well. So you have the blobs in some form of blob storage in a bucket on GCP or AWS. At the same time, you have the embeddings either in a transactional database if your dataset is small, or in a vector database if you have to serve them for a more real-time or near real-time application. And then you also have the metadata, which is often stored in something more structured, most likely a transactional database like Postgres. So you have a lot of different storage solutions, which makes it very hard to work with multimodal data. And in AI, you have a set of operations all of that has to support. For example, you want to access data randomly. So you actually can run your training, you can do a train test split, and at the same time it has to support filtering. Because during training, for example, I want to do a stratified sampling because I don't want to split completely randomly, because there might be some patterns in my data I have to consider. Or in time series data, when I'm doing an anomaly detection, I want to split based on the datetime column to only run the predictions on future data points and train on past ones. So it isn't enough to have completely random access, but I need it, but also based on basically a certain column I have to be able to filter. At the same time as the dataset evolves, I want to be able to version it, but I also want to be able to use the metadata in the best case where it lives with the raw data. And Lance is trying to build the solution for that. At the moment, they're really optimizing for large scale storage. So really going like 10 billion, 50 billion vectors plus. And how they do that is by building a solution on top of file storage or blob storage, on top of S3 GCP buckets. And this means the storage is very, very cheap. And they do that by separating the compute and storage, by building their own open table format, which is Lance. And for those of you who don't know it, an open table format basically is a file format plus metadata. And there are some open table formats which are more for transactional or BI, business intelligence workloads like Hudi, Iceberg, but also Delta Table. And they basically store the raw data in Parquet and add metadata in JSON files to allow ACID transactions, to allow versioning and stuff like that. And Lance has built their own solution for that, but building on top of their own file format, which allows for additional query types and access patterns, and also, for example, similarity search on disk-based indices. And we will be interviewing Chang, which is the CEO of Lance, but also one of the original creators and maintainers of the Pandas library. And we'll be diving into how Lance works, what use cases stand out to him, what Lance is used for, how you can use Lance for your own projects, and also how to build retrieval, search, RAG, but also recommendation systems on top of Lance. Let's do it.
Lance is the database for AI. So we help our users who are generally AI teams looking to build AI applications to manage their data, to do performant billion scale vector search, and also deliver better performance for training, fine tuning, and the whole sort of data infrastructure needs throughout their AI lifecycle.
Yeah, great. And can you tell me your story, how you got actually into building LanceDB and the file format Lance? What was the problem you actually seen in your day-to-day life that convinced you to go into the space?
It's very interesting because so much has happened over the last year. We started LanceDB about 2 years ago and working on a sort of related but very related problem, but in a very different form. We started because I was at 2BTV, a streaming company, and my co-founder Lei was at Cruise. And what we saw was that there was so much pain for ML teams when they were working with unstructured data for multimodal AI. These are like images, videos, audio tracks, PDFs, point clouds, you name it. So in the new era for machine learning and AI, the data doesn't really fit well into a table. And so all of the data infrastructure was not optimized for that. And our teams just had a terrible time dealing with that in production. So we wanted to create a new generation of data infrastructure that makes their lives a lot easier. And this is really informed by my experience in open source. So I've been building data tools for machine learning engineers and data scientists for almost 2 decades at this point. I was one of the original creators of the Pandas library, and this is my passion is I love sort of creating a tool and seeing the users get a 10x boost in productivity or just getting superpowers. That's what makes me happy. And so we wanted to do that for this new generation of multimodal AI applications.
Yeah, and that's especially like the big trend at the moment I'm seeing as well in the data space. There are so many libraries popping up which are streamlining so much of the process and which are actually focused on improving the performance so much. And most of them are actually based on Rust, like you are. What was the decision to actually jump onto the Rust train?
Yeah. So our Rust pill moment was the end of 2022. So we had spent a good portion of 2022 in C++ writing the core Lance columnar format. And this was used by our early customers, mostly in autonomous vehicles, to manage petabyte scale vision data sets. And one of the things, more than one, with C++, our frustrations were it was very easy to write unsafe code that creates segfaults in production when you run it. It's really difficult to wrestle with CMake. And overall, it was just difficult to move very quickly and be very agile. And the Christmas of 2022, we were just having a hackathon project for a customer demo. And we said, hey, let's learn Rust. So we wrote that and we were just amazed by how productive we are, how easy the tooling ecosystem was, and how confident it made us feel because the code that we wrote was so safe. And as a Christmas present to ourselves, we decided to say, hey, let's make a big bet on Rust, ditch all of our C++ code and rewrite it all in Rust. And so we did that in the new year, and it took us about I think 3 weeks to rewrite roughly 5 months of C++ development. Yeah, and as learners, beginners in Rust, and I think that's not a unique story to us. So like a lot of I've heard from a lot of friends who are rewriting things in Rust that they were able to just move a lot faster because of the language.
Do you see actually more companies which are implementing AI and not really developing like the infrastructure, the libraries for it, switching to Rust as well? Or do you see Rust rather as a support language for something like Python, where a lot of the libraries are actually implemented in Rust and you use it in Python just for the ease of use?
I think in terms of number of users, we will still see the largest usage in Python, just because the Python ecosystem for AI is so rich and has so much tradition. But we're starting to see a lot of the sort of AI application or AI infrastructure companies use Rust under the hood for their systems and services. And as that happens, a richer Rust ecosystem is also coming up so that a lot of these systems can now talk to each other directly in Rust rather than having to use pure gRPC HTTP protocols or have to go through the Python layer.
Yeah. And now jumping back into LanceDB and Lance, what are the major components for the developer when he's interacting with LanceDB and when he is actually using the library for basically data insertion, but also vector search?
Yeah. So for LanceDB, we built that around our core Lance format. And so we built essentially when users are interacting with LanceDB, they are interacting with either the Python, the Rust, or the JavaScript APIs, and they're talking to a query layer that then wraps around Lance format. And so we try to build it so that it feels very familiar to users who are used to using the usual data tools, especially in Python. For example, you can insert data into LanceDB using Panda's data frames, Polar's data frames. You can plug uh, Lance into, let's say, like a Spark cluster, and you can write massive amounts of data very quickly. We have one sort of user this tells us they have a 10 trillion token data set that they're writing into Lance in a massive Spark cluster. And so from small local experiments with pandas to really large embed the internet kind of workflows. If you're used to the sort of traditional Python toolchain for working with data, it's very easy for you to work with LanceDB. And I think one of the interesting things that I feel personally pretty passionate about developing LanceDB is we're big believers in the composable data systems vision. So my old co-founder from my previous startup, Wes McKinney, he really made this popular when he was at Voltron Data. And so the idea was, hey, the database is going to get blown up, and we're going to have in each layer, we're going to have really great open source projects that make it easy to talk to each other. And you can now easily create very customized data systems by just picking and choosing the right projects and putting them in the right package. And so we follow that philosophy so that our internal query engine, for example, we use Data Fusion. We use Apache Arrow as the in-memory API into the rest of the ecosystem. And so automatically we're getting compatibility with dozens of tools that have integrated with Arrow already.
If I'm looking at databases often, it's like you have a pretty fixed process. So first I have like data modeling and defining a schema, then I'm setting up the database, and then I'm actually inserting the data based on the schema, and then I can start querying. What do these components look like in LanceDB?
Yeah, so under the hood, the schema is Arrow schema, is everything in the interaction is Arrow. But one of the things that we've integrated into LanceDB that I think is really helpful for our users is pedantic. So Arrow is great for infrastructure, but as a user-facing tool, the API is not necessarily intuitive all the time, to put it lightly. And so what we do is we actually allow you to create the data model using a pedantic model. And we take care of the conversion from pedantic to Arrow. So when you create a table, it's very easy in Python to say, I don't really know what the arrow types and all that are, but it's very easy for me to just create a class that inherits from pedantic base model. And I can use that as the schema. And then I can also just pass in pedantic object instances directly into LanceDB, and it knows to translate that into the database schema. And additionally, So what really allows us to do is we've got this embedding registry functionality that allows you to say, hey, this column or this pedantic field is the vector column, and it's going to be generated using OpenAI or sentence transformers out of this source attribute in the same pedantic schema. So once you do that, when you create the table, you now no longer need to do embedding generation, either when you insert data or when you query the database. So now, instead of this sort of simple vector search tool, we can now give LanceDB as a search backend, a more generalized search backend for our users. So they can just throw in text or throw in images, and they can add in text embedding functions, image embedding functions, text image multimodal embedding functions. And it's very easy for them to say, I want to query vectors, or I want to do query keywords, and they don't have to deal with most of the details under the hood.
Yeah. And what other indexes do you support in Lance? So do you, because Postgres is particularly known of having like a shit ton of support for different data types, how is it looking for Lance? So do you also have like geographical data types which you can query, or date times?
So daytimes, definitely, we have support for that. We generally support most of the arrow data types, and we have rich semantic types on top of that. So for example, we have a semantic type for vector, and the storage is fixed size list. We have semantic types for tensors and images, and we're making one for video as well. I think the type ecosystem is very rich in Lance. And what's interesting, I think, is when you bring up the type ecosystem, is that Lance is a little bit different from other vector databases in that we let users actually store the raw data, and especially the training data. We have some of our largest customers, right, storing petabytes of image data for training in the same data set that there's you storing the vectors for serving. So this gives them that single source of truth, so that they don't have to keeping two data sets in sync with each other and things like that.
Yeah. And you have on your website actually the phrase which I really love is like up to 1000 times faster than per K. What is the main optimizations you actually do below the hood to get that performance benefit?
Yeah. So all benchmarks are wrong, but some are useful, right? So the whole overall context on that sort of 1000 time claim is, for machine learning and AI, a lot of times dealing with the data means you need very fast random access. So this is useful for indexing when you do shuffling or sampling and things like that. And so when you want to fetch a small number of rows scattered throughout your data set, that's when we can get up to that 1000 times speed of Parquet. And then I think sort of the reason why we're able to achieve that with the format is because we lay out the data differently from Parquet. The sort of IO plan for the data set is also different. And we've updated a lot of the access assumptions based on more modern storage technologies, right? Parquet was designed 10 years ago, and storage technologies were very different then, especially there wasn't there wasn't as prevalent usage of cloud-based object storage, for example, and NVMe SSDs weren't really around, or weren't nearly as fast. So by doing all three of those things, we can achieve very meaningful performance gains.
Yeah. And when I'm looking especially at the Lakehouse ecosystem as well, they are also trying to basically abstract away the complete storage element from the user and do all of the different optimizations below the hood. And especially in Delta Table, I think what's prevalent now, or what's coming, is liquid clustering, is what I call it, I think, where they try to group the similar elements which are likely to be retrieved together, where they try to group it together. Have you considered such optimizations as well?
Yeah, so we've added stats-based pruning in the format already. So typically the use cases for these types of things are just for much faster filtering under the hood. And on top of that, because we actually support fast random access, it's easy to then attach an index for that. So that increases filtering performance even more, especially if your filters are very selective. And I know that like Delta under the hood uses Parquet for storage. And same with Iceberg and Hoodie. In those types of use cases, Lance is going to be much faster because the file format is different under the hood.
Yeah. And looking at Delta Table, Iceberg, and Hoodie, what would be use cases where you would go like with more of the old formats over Lance?
I think for now, if you have just very traditional BI use cases where the vast majority of your workload is just scanning one column for filtering and then scanning another column to compute some aggregate, right? And these are like just tabular data columns, then there's probably not a compelling reason to switch. And if you're already in those ecosystems, there's not a compelling reason to switch out for those use cases. So I would say that. And Lance is as good in performance as Parquet and the systems built on Parquet for those types of use cases. But Lance is much more optimized if you're working with embeddings, if you're working with images and large blob data.
Yeah. And what we already touched upon is like the multimodal part. And this is particularly interesting, especially getting into more and more of the multimodal models, what we are seeing right now. And what use cases do you think LanceDB will enable in the future through this multimodal storage and the associated embeddings, which are all stored in one place together?
So I think we're seeing a lot of these use cases in a nascent form already. So I think one is being able to quickly train models for multimodal use cases. For example, you get in your car and you can say roll down. You can point to one of the windows, say roll down that window, or turn on the radio and play something I like, or just when with VR and mixed reality, also with different attempts at glasses and vision. I think there's a lot of room for those types of applications. Now, the interesting thing is, this is where I think multimodal models, especially like vision models, are very different from large language models because in production, the language that you see is pretty similar in distribution to the language that LLMs are trained on, right? But for vision models, that's not necessarily the case. Like large vision models by default are trained on, I don't know, like stock images or something like that, right? Or like Coco or ImageNet or whatnot. But in production, there's no control over that. If you're using that in a chip manufacturer, they're all going to be top-down images of like your board. If you're using them for autonomous vehicles, they're all going to be street scenes, and you're going to be picking out very specific classes of things. And so I think for multimodal AI, there's going to be a lot bigger need to at least fine tune your own model, if not completely retrain it. And so the need for data storage and data management then becomes much bigger. And I think along with that, for AI in production, I think a lot of the success factors are going to be the same as classical ML. Um, it makes me feel really weird to think classical ML is 2 years old or maybe 1.5 years old, but here we are. And I think the biggest thing that I learned from Tubi was that machine learning and generally AI success depends on the speed at which you can iterate and experiment. And so having something like Lance gives you a lot of advantages. So for example, one of our users told us, hey, I've got, I think something like 100 terabytes of image and video data in S3. When we want to run an experiment, we have to download all of that data, create the new feature data as a new column, add that into the new copy, and then upload it back into S3 as a new copy. And so this makes it incredibly expensive, and also it takes incredibly long to run every new experiment. But instead with Lance, you can keep that same copy and you don't have to load it anywhere. You just write new feature data as new columns directly onto S3, and you can roll back in time, so you can discard experiments that have completed and you won't roll out into production. So I think use cases like these are what I'm really looking forward to helping our customers and users do in 2024 and 2025.
A few use cases, especially listed on your platform, which are RAG, which is the obvious one, let's say, and search.
Right.
And one I'm particularly interested in is the recommendation systems use case, because I think in the near future, we will see more and more of people realizing that most of the stuff we are doing with LLMs at the moment is recommendation system, especially in RAG. We're recommending the right pieces of content, but also with the trend of shifting the computation to inference time, that we generate multiple different options as answers, as texts, where you in the end have to put a recommendation system on top of that, which answer is the most relevant. I think we will see more and more of that. And I'm really curious, how would you set up the typical recommendation system data model, like having items, having users, and then having the analytics? How would you set this up in LanceDB?
Yeah, this is very interesting. I think so let's talk about what's similar, right? And so the problem is you want production quality retrieval that is tailored towards our target, right, in both. And so the way that Rexus solves it is you have a first pass sort of recall step that uses a bunch of different retrieval techniques to get relevant data. Then you put them all together and you pass them through a re-ranking model to do fine-grained re-ranking, right? And then you present that results to the user, usually in either some sort of feed format or some grid format, depending on if you're talking about news or streaming or e-commerce or things like that. And then what's really interesting about Rexus is, of course, you can take that user feedback and you can now fine tune your system. You can change your recaller models, you can change your re-ranker models, and you can add additional sort of business logic rules to change the rankings in a non-machine learning context. Now, with RAG, so far it looks much simpler than that, right? We just say there's a recaller step. Typically, most people are just using vector search, so a single recaller. There's no real re-ranking, but we just feed the results into that LLM query. Now, when people go into production, what they're looking for is, okay, vector search gets me maybe like 60 or 70% of the actual results that I want from my knowledge base. How do I do better? I need to get to maybe 90% in order for my application to feel production quality to my users. So now we have a lot more experiments in production around, okay, instead of just vector search, you can now add keyword search, you can do SQL queries, or even add graph databases or something like that, right? And so now you have multiple recall results, right? Now you need a way to combine them and re-rank them. And of course, I think the new term is now rank fusion, but it's basically just re-ranking, right? And then you're presenting the results to the LLM. So it's really starting to look very similar. And what's missing is that feedback cycle of, okay, can I take user feedback and can I fine tune the embedding model, for example? Can I fine tune the re-ranking model? And I think in LanceDB, we're working on that closing that loop in a more automated fashion. A lot of our users today are doing that themselves, and we want to make that easier. We recently released a much more complete workflow for hybrid search and re-ranking. But so I think soon we'll have this sort of complete story and it'll look very similar. Now, there are, I think, some important differences, right? Because when you talked about Rexus earlier, you mentioned, hey, we have users and items and analytics, and we're recommending the items to the users. The issue with LLMs is you're not recommending results to a user. You're actually recommending results to a query. And so it's the results are, even if they're issued by the same user, different results are going to be relevant for different queries, even if by the same user. And I've been discussing this with a friend of mine, Brian Bishop. So any insight that sounds interesting is probably coming from him and not me. It's only secondhand. Yeah. So I think so the systems won't look exactly the same, right? You won't
Yeah.
have this like really simple users item dichotomy, and it's going to be much more sophisticated. At a high level, it does look very similar.
Yeah. And I think what's already pretty pronounced in recommendation system, you always have a secondary storage at least for the embeddings because they tend to get quite large. Would you envision a future where you also do user-based, content-based filtering or even collaborative filtering? How would you integrate this into Lance if you would want to enable this more?
I think so. With collaborative filtering, essentially, what you end up doing is you end up generating the embeddings for users and items that way. And so if we're generating like item embeddings using an OpenAI or some embedding model, you probably won't need something like collaborative filtering or these traditional techniques, Rexus techniques. But you still will have item embeddings. Now it's not clear to me what the user embeddings will look like, but I could envision a future where the results, the way that we recall results and the way that we re-rank them can differ based on the user. And typically this would involve some sort of feedback mechanism that allows us to estimate a distribution for given users based on what types of questions they tend to ask, what types of responses are more relevant to them, and things like that. So we haven't done all the work to test that out yet. So this is all sort of speculation at the moment.
Yeah. And can you tell me, like, what is the most surprising, interesting, unexpected way Lens is used in production right now you've seen so far?
So there are a couple of, in retrospect, not surprising, but when they were presented to me, was very novel. It made me say, "Huh, I didn't think of that." One was interesting. There are a couple of desktop applications that use Electron that now use LanceDB, and they have local vector storage, and some of them have even local LLM or make a chat GPT call or something like that. And so that was very interesting when we set out to make the data format and the vector DB. We hadn't even thought about desktop applications in a long time, but it seemed very useful and it was great. I think there were lots of rough edges, especially around Windows distributions that we've ironed out, and there's some issues that we probably still needs to fix. For those guys who've built on top of LanceDB, thanks for your patience. And so that's one class of applications that's been really interesting. Another type is actually, we've had a couple of like newer machine learning frameworks that are now building on top of Lance format. And a particular one was very interesting. There's a framework called APN ML out of Fujitsu in Japan. And when I talked with those guys, uh, their goal is to use Lance not just for the data storage, but when they train models and when they create new model artifacts, they actually want to store the models in LanceDB as well. And what's interesting for them is one, LanceDB is automatically versioned. So as you accumulate more artifacts, it's very easy for them to manage the different versions. And that's one. Two is they can keep the models with their metadata as part of Lance and be able to work with that easily. And then number three is once they've stored it in Lance, they're still trying to figure this part out, but you can create an embedding out of the metadata of that model. And now you have a model database that is semantically searchable. So their users can come into the system and say, I want to compute like I don't know what they would, I think they're saying like, I want to solve this classification problem using these kinds of data, and they'll be able to essentially recommend the right models to their users using Lance as that search backend. And the interesting thing that we're still trying to figure out with them is what is the right thing to embed to make these model artifacts searchable? Is it if it's a description, how do you make sure their users are actually putting in useful descriptions? If it's something else like a code artifact, what are the relevant things that will support semantic search like that? That was also very surprising and very interesting. And I think this is something that makes me think LanceDB might be really useful for agents in the future as well. So if you have agents that starts to collect lots of different capabilities, you don't want to say, okay, my agent knows how to do 100 things. I'm going to send them all to ChatGPT function calls as context and get something back. You want to, pick the most relevant few and send that to ChatGPT.
Yeah.
And this is where I think LanceDB can come in as a semantically searchable function registry for agents, if you will.
Yeah, like we've seen in the Voyager paper, where they're also embedding the actions the agents learned. Nice. So what tool would you love to see being built on top or next to Lance, which would make it even more powerful?
That's really interesting. Yeah, I think what I'm looking forward to immediately is sort of bigger integrations into the data ecosystem. And so we want to enable our users to not have to think about that whole like data preparation pipeline and ecosystem and all those tasks, and be able to think, okay, I can just throw data and LanceDB, and then on the other end, I'm going to be able to run search results. Small to large data systems being connected at a native level. I think that's what really excites me, is to get more data in. And I think I'd love to see, going back to that agentic workflow, we now have some users that are like a very domain specific multi-agentic workflow that they're trying to push into production. So I think it would be pretty amazing to work with them to build these semantically searchable function registries and capabilities into LanceDB. I think RAG, we've done a lot of that in the past year, and I think everybody's probably sick of chatbots by now. And I think multimodal and agents are the sort of next frontier. And so I'm really looking forward to seeing what our users will build on top of LanceDB in those areas. Yep.
Nice. So what's next for LanceDB?
So I think the next thing on LanceDB is continue to optimize our scale and performance and ease of use for users. And I think start to deliver on a lot of the topics that we talked about today, of how to make it easy for folks to create a Rexus in RAG, how to make it easier for people to embed the internet and quickly ingest that and index that and make that searchable. So I think a lot of that is driven by the fact that, hey, this year AI teams and individual developers are really trying to seriously build generative AI applications in production. And so how do we serve the needs that are different in production that weren't really a problem last year when it was mostly like demos and POCs?
Yeah. Nice. So where can people follow along with you and with LanceDB?
Yeah, absolutely. I'd love to chat with folks on Twitter or GitHub. It's the same handle I've had for 25 years, I think, which is Genghis Khan. And we have a Discord community for LanceDB, and it's pretty active. And there are lots of really interesting applications and use cases that you can see in there. Yeah, and I'd love to talk shop on Discord or on Twitter, or if they just want to ping me privately, I'm Chang at lancedb.com.
So what can we take away when we want to take stuff into production? So I'll be fanboying a little bit because I love LanceDB and I have it in production in 2 separate projects. So I can't recommend it highly enough. So first, it's open. And I think they built a solution in a space where there wasn't a good alternative. And there are two main areas I use Lance. One is large scale embedding and data storage. So basically keeping everything together when I have a lot of embeddings, a lot of raw data, but also the associated metadata. And this can be, for example, image data plus bounding boxes, which is often stored as more structured information. But it can also be, for a recommendation system, images plus text plus the embeddings to do a recommendation system or a search on top of. And basically just keep a caching layer in front of it to keep the latency at a level that I actually need it for the application. And I think that's what they actually built in their hosted offering of LanceDB. Is basically a solution which combines like the scalability of LanceDB, the open source project on top of S3 or whatever cloud storage they are using, plus a really smart caching solution which has a good way of basically invalidating the cache and also filling the cache with the data that you need in low latency. And that's in the end for you to figure out like what data is important and what data will be requested by the user the most. So you actually, it's valuable to keep it low latency. And I built mine in Redis because it has instant updates to the index, which is something I learned fairly recently, but I think you can rebuild that stack pretty fast. And Lance, the second area where I use it is embedded. I think he went into a few of the use cases of, for example, VR, AR, or vehicles, where you would actually use something like Lance as a vector store. The advantage of using Lance is that you actually don't have to waste memory. So when you're in a resource constrained environment, you actually want to focus that most of the RAM you're using is actually going into some form of business logic or some important processes that are happening on the end device and not on storing vectors and making search very fast. And I think Lance is a good solution for that. I also use it on if I have use cases where I'm not running a real-time search, but there are documents or some form of information coming in and I'm processing it live and I'm not really storing it in any way. So I'm basically just creating a Lance table with the embeddings, with the additional information, and just querying on top of that. And this also makes it very efficient because I just can use a Lambda, attach a little bit of file storage, and don't waste my memory for keeping the vectors, the embeddings in memory. And this is, I think, what makes Lance very special, that you actually can decide like where to put your resources in the end. I think use Lance, try out the tutorials they have on their websites. They have some really good stuff. Check also their blog posts and their documentation. I think it's one of the better documentations out there explaining the different components behind Lance. And follow Chang. And if you want to see some of the things I built with Lance, let me know. Give me a ping on LinkedIn, on Twitter, or somewhere, and I might make it open. I'm not entirely sure. I might have to do some adjustments. Otherwise, we will be continuing on multimodal AI on Thursday. So in the next episode, if you're catching this later, where we will be talking about fine-tuning multimodal embedding models with Michael Günther, who is a researcher at China AI. I'm really excited for that. So give it a follow wherever you're listening on YouTube, Spotify, Apple, or wherever else. And I would love to hear your feedback on this episode and especially like what stuff we could improve. Like the critical feedback is always more welcome because it helps us improve the podcast. And yeah, I will see you in the next episode and hopefully talk to you soon.